Section 9.4 is on using the square root property to solve quadratic equations. We already know one way to solve a quadratic equation, by factoring. So we're going to first use that method to solve the equation x squared minus 16 equals 0. This is a difference of two squares, so it's going to factor into x plus 4 times x minus 4 equals 0. And since you've got a product equal to 0, you can set each part of the product equal to 0. So x plus 4 equals 0 and x minus 4 equals 0. Subtracting 4 from each side gives you x equals negative 4, and adding 4 to each side gives you x equals positive 4. So this equation has the two solutions, negative 4 and positive 4. Now we're going to solve this same equation using the square root method. Okay, to use the square root method, instead of having it equal to 0, which is necessary for factoring, you're going to want to get the perfect square alone on one side of the equation. So for example, I'm going to add 16 to both sides. So this is going to be x squared equals 16. So just add 16, add 16. The perfect square is by itself. Make sure that when it's by itself, there are no variables on the other side. If there are, you need to pull them back to the other side. It's not going to work out if you have variables on both sides. They need to only be on one side. So to take the square root of both sides, I'm going to have to include both positive and negative square roots. There are two numbers that when squared gives you 16, positive and negative 4. So if you take the square root of both sides, you have to write in the positive and negative square root of 16, or the positive and negative 4. Often we use this plus or minus sign to, in one line, symbolize both positive and negative 4. So there are two answers here, positive and negative 4. So the answers should match no matter if I solve by factoring or solve by the square root method. And once again, you need to remember to write in plus and minus whenever you take the square root of both sides of the equation. Let's look at another example. So the square root property says that if I have x squared equals k, it has the two solutions, x equals positive and negative the square root of k. So let's solve x squared equals 9. Okay, x squared equals 9. Take the square root of both sides, I get x equals plus and minus square root of 9, or x equals plus and minus 3. Right? Now I just want to talk for a moment about the square root symbol. The equation x squared equals 9 has two solutions, positive 3 and negative 3. The square root of 9 itself is the one number 3. That's why I have to really make sure that the act of taking the square root is the act that creates the positive and the negative here. If you just write the square root of 9, that only represents one number. So it's the plus and minus in front of the square root that complete my answer here. Alright, so a few more to solve. X squared equals 7, so that means that x is going to equal plus and minus the square root of 7. The square root of 7 cannot be simplified, so that's our answer, plus and minus the square root of 7. In part B, I want to get this equal to 50, so we're going to add 50 to both sides. I need my perfect square by itself. So r squared equals 50. That means that r is going to be equal to plus and minus the square root of 50. Now, unlike 7 over here, the square root of 50 is not simplified, so we can do a little bit better. We can simplify that square root. So r equals plus and minus. We know that 50 can be written as the square root of 25 times the square root of 2. So we're going to be able to simplify this to 5 times the square root of 2. So positive 5 times the square root of 2 and negative 5 times the square root of 2 are my two answers. If you're typing your answers into my math lab, you are going to need to type them with a comma separating them. So you would type these as 5 times the square root of 2 and negative 5 times the square root of 2. But on paper, for shorthand, you can write plus or minus in front of the 5 to represent the two answers. Okay, part C and D, we've got a couple equations we want to solve using the square root method. We need to get our perfect square by itself first, so let's subtract the 5. That'll give us 3x squared equals 75, 80 minus 5. And the perfect square isn't by itself because it's got a coefficient of 3, so we better divide both sides by 3. So we've got x squared equals 25. Now take the square root of both sides, and you'll have x equals plus and minus the square root of 25, which we know simplifies to x equals plus and minus 5. So positive 5 and negative 5 are the two solutions. Okay, let's check part D. In part D, the perfect square is a parenthesis unit, not just an x like it was in part C. So I'm going to take the square root right from the beginning because the perfect square is by itself. So I'm going to get 2x minus 1 equals plus and minus the square root of 49. And I know that's 7. So I have 2x minus 1 equals plus and minus 7. Now I have to separate this into two equations. I can't add 1 to plus and minus 7 because they're two different numbers, 7 and negative 7. So we're going to write this as 2x minus 1 equals 7 and 2x minus 1 equals negative 7 because there's more work to do in solving this equation. Okay, the plus and minus wasn't the last step here. Add your 1. We have 2x equals 8. Divide by 2. One of our answers is x equals 8 divided by 2 is 4. Let's look for the other answer. Add the 1. 2x equals negative 6. Divide by 2. The other answer for this one is x equals negative 3. Let's go to the next page. Example 4. We've got a few more problems to solve using the square root method. N squared. So the 8 is not part of the n squared, so we're going to divide the 8 over. So that gives us n squared equals 3/8. Take the square root of both sides, you get n equals plus and minus the square root of 3/8. The square root of 3/8 is not simplified. For one, we're not allowed to have a square root over a fraction, so we're going to separate this into the square root of 3 and the square root of 8. Now that needs to be rationalized, so we're looking for the smallest perfect square that 8 goes into, and that'll be 16. So to make it a 16, we're going to have to multiply top and bottom by the square root of 2. The square root of 3 times 2 is 6 over, well, I'm going to have the square root of 16 there, and I know the square root of 16 is 4. So my final answer is n equals plus and minus the square root of 6 over 4. Let's get our perfect square, the x plus 3 squared by itself, so we're going to add 8. It's going to give us 2 times x plus 3 squared equals 108. Divide by 2. The 2 is not part of the perfect square. It's on the outside of the parentheses. We're going to divide that off. To get the perfect square by itself, 108 divided by 2 is 54. Now that the perfect square is by itself, we're going to take the square root. So we're going to have x plus 3 equals plus or minus the square root of 54. This can be broken down into plus or minus. 54 is 9 times 6. 9 is the perfect square. So I have x plus 3 equals plus and minus the square root of 9 is 3 times 6. And I need to subtract the 3 over to figure out what x is equal to. So if I subtract this 3 over, since 3 is not going to be a like term to 3 square root of 6, I can just stick it in the front. I can say x equals negative 3 plus or minus 3 times the square root of 6. So these two answers, if you're going to write them separately, would be negative 3 plus 3 square root of 6 and negative 3 minus 3 square root of 6. Those are the two answers written separately. A couple more here. In part C, to get the square by itself, you're going to want to divide both sides by 9 since 9 is not part of the square. So if I divide by 9, I will have x minus 2/3 squared equals 8/9. Now to get rid of the square, we'll use the square root property. So we're going to have x minus 2/3 equals plus and minus the square root of 8/9. We already know that we can't leave a fraction inside of a square root, so we're going to separate this into the square root of 8 over the square root of 9. Keep simplifying because your square root is not yet simplified. So I've got x minus 2/3 equals plus and minus. Okay, I know on the bottom that the square root of 9 is 3. And on the top, the square root of 8 can be broken down into the square root of 4 times the square root of 2. So I have plus and minus 2 square root of 2 over 3. Now, to solve for x, we're going to add the 2/3 over. These aren't like terms, so we're going to write it as x equals 2/3 plus and minus 2 square root of 2 over 3. I can't add a 2 to a square root of 2, so they're not like terms, but they do have the same denominator, so I can combine them. They have a common denominator, so this will be 2 plus and minus 2 square root of 2 over 3. Okay, let's look at part D. The perfect square is already by itself, so I'm going to take the square root of both sides. So give me bx minus d equals plus or minus the square root of k. That can't be simplified because it's a variable, not numeric. I'm solving for x. So for next thing I want to do is add d to both sides. So it's going to give me d plus and minus the square root of k. Now to solve for x, I need to divide both sides by b. So my final answer here is going to be x equals d plus or minus the square root of k over b. Alright, let's check out the next page. In example 5, the poverty threshold in dollars for an individual under 65 years old in the United States can be modeled by the equation P equals 4.95 times T minus 57 squared plus 1406. Find P of 95. Okay. P of 95 just has us plug 95 into the equation for T. So we're going to have 4.95 times 95 minus 57 squared plus 1406. So that's 4.95 times 38 squared, if you simplify, plus 1406, and then you can simplify the rest of that to get 8,553.8. So what does this mean? We're talking about years since 1900, so 95 years since 1900 is going to be the year 1995. So in 1995, the poverty threshold for an individual under 65 years old was $8,553.80. In the next example, we want to find when P of t equals 3,000. So we're going to plug 3,000 in for P of t and set that equal to 4.95 times t minus 57 squared plus 1406. This is a perfect square, so we're going to solve this by first subtracting the 1406 from both sides. That's going to give us 1,594 equals 4.95 times t minus 57 squared. Now I've got to divide both sides by the 4.95. And at this point, we're going to have to start rounding. 1594 divided by 4.95 is about 322.02 equals our t minus 57 squared. And now we need the square root of both sides. So we're going to get plus and minus the square root of 322.02 equals t minus 57. So I'm going to get two answers here. One of them is going to be the positive square root, and one of them is going to be the negative square root. So if you use your calculator, take the square root of 322.02, you're going to get about 17.94. So I have plus and minus about 17.94 equals t minus 57. Because you can combine these, you can add these values up. We're going to need to separate this into two equations. We're going to have negative 17.94 equals t minus 57 and positive 17.94 equals t minus 57. When you add 57 to both sides, in the first one we get about 39.06 equals t, and in the second one we get about 74.94 equals t. So what do these mean? These are t values, and so these are the years. So there are 2 years since 1990, so it's going to be 1939 and 1974. The poverty threshold was $3,000. What is the vertex of this model? Find the vertex. This is actually written in vertex form. Recall that when an equation is written in vertex form, we can identify h and k right from the equation. So the vertex of this model is 57, 1406. And this means that the poverty threshold in 1957 was $1,406 for persons under 65. Also, because this is the vertex, we can mention that this is the lowest the poverty threshold ever got. We know it's lower because we know that it was higher in other years. So the vertex is the maximum value, the minimum. 1,400 cannot be the maximum because there were values such as 3,000 that were larger than it, so it must be the lowest value. The other reason I can tell that it's lowest is that my A, my coefficient, is a positive number. So this graph is going to be facing up, and so therefore it has a minimum.